Okay, so nothing new here. You've probably seen us do this a few times now, but once again we have a 69, 1 year only, master cylinder that needs to be gone through. This is a situation where you bleed the brakes and everything's fine, then over time the brakes completely go to the floor. You're not losing fluid, it's just that we're trapping air. The only place we found that was even remotely suspect was the boot around the master cylinder was wet, so obviously we're having an exchange of fluid with atmospheric pressure right there. So in an attempt to try to save this one, we're going to just rebuild this one, hone it out again, and see what we can do to save this one. But again, especially if you're looking into buying one of these cars, if it's got brake issues, just keep in mind the 69 is one of the more expensive ones to try to save because it's a 1 year only brake setup and the parts seem to be pretty expensive. Okay, so we're taking the master cylinder out of the parts washer, and once we cleaned the actual barrel of it, it seems pretty clean. There's no edging, no grit in there. It doesn't seem like there's a whole lot of sedimentation in there. So that's all fine and well. But once again, as we've talked about before, this is probably one of the most intricate and important parts of the actual system. This is the rear piston assembly. You see there's 3 different O-rings on there. You have to make sure they all go the right direction in order for this to work properly. The other one is this. This is the front one. In other words, when you take the actual actuator off, this is the first thing you're looking at. This one's a little more critical on a different point. Right here are the metering holes. These are bleed backs. That's when the fluid's being pushed and allows it to be able to come back. They get restricted all the time. This makes for vague braking if these are restricted, and they get restricted with a lot of sediment. Now, when we first started this car, the fluid in it was almost black. It means it's highly contaminated. It means it's also hydroscopic. It means it's got a lot of moisture on steel lines. It's all cascading effect, and all sediment is going to settle to the lowest point of the actual braking assembly. That lowest point of the braking assembly is the master cylinder on the 69. Which means everything's going to sit right in here and accumulate around this, and it's going to get clogged. And it's going to make it very vague braking. So if you are going to rebuild yours, which isn't a hard job at all, but if you're going to rebuild yours, make sure you take the time to clear these holes out. You'll be much happier and your brakes will respond much better. Okay, so once again, this is the rear, okay? You got this retaining ring, you got to get off. And then this will slide right out. This is the only thing you have to do to it. The rest of these you can get out with a little O-ring hook. So once you replace this, you're going to put this back on. Odds are it's not going to bite. So a simple little thing. Take a 9 or 10 millimeter deep socket. And just tap it off. That's not going anywhere. You just got to go to it. That's it. And this one's ready to go. Okay, so what you're looking at here is probably one of the rarest cars that we get around here when it comes to the modern day Alpha. It is a 1970 1300 Junior. This car was never sold in this country, so they're exceptionally rare for us. But this is a fairly clean, fairly honest car, and it's finally coming out of our stables and going home. Anyway, one of the things we're doing is we're improving the suspension on it, and I say that haphazardly. Why? There is no right and there is no wrong true answer when it comes to suspension and what should be running. So in this particular case, you can see it has these springs on it that are fairly close on the winding, which means that there's very little compression going on there. And they also have aftermarket shocks, which are the Coney Reds. For the longest time in this part of the country, had a bad habit of believing that the ideal situation for suspension was really rigid, tight springs, which means they didn't compress very much, and brutal shocks. You know, years ago that was ideal for a track car, but that most certainly was not an ideal situation for a street car. And there's always some version that in between that will work for anybody. But in this particular case, or in any particular case for a street car, you have to really think about what the application you're using. Street application and race applications are two different things. If there was something in between where you could do both, then you certainly need to find what is more relevant to you. But quite honestly, when you're in a street car with reasonable profile tires, with original size tires on this, why have brutal shocks and brutal springs that absolutely make you feel every inch of the road? There's far faster compliant setups that are soft enough, fast reaction, and still very straightable and gives you a comfortable ride that you don't want to get beat up after an hour on the road. In this particular case, we're going with what I feel is a little more sensible for a street environment. We're using, and all these aftermarket companies produce it, we're using a road kit, as it's called. What it is, it's a little more compliant spring, very fast reacting sport shock. And that kind of makes the car a little more civilized when you're just trying to enjoy a nice Sunday drive on a back road somewhere. Is it something you necessarily want to use in a race type like or competitive environment? No. But if we're going to do track day events, it is a little more prepared to use in that environment. So it's strange because there's a lot of hard thoughts you have to kind of break the cycles of. The heavy duty, very rigid springs and fast reacting shocks are ideal for any given road course. When you think about it, because most tracks are very smooth tracks, they're not like your streets that you're requiring the city or the state to maintain. So in those cases, those work well. But do they work on the street? No, they don't. I've been in a million Alpha, and I gotta tell you, every time you get in one with heavy duty springs and shocks, you know it's just brutal. Especially when they start to use low profile tires. There's no yielding in this. You're gonna feel every inch of the road. That's not an experience that I would call positive. That is just, somebody's got the car race prep and they never go to track. It's strange. Anyhow, I think you find you can enjoy your car far more if you're mostly in the application. If you have something that's a little faster reaction, meaning a spring shock combination, but yet also a build that doesn't beat you up going down the road. Some of these road packages with improved sway bars and more compliant springs, more sensible shocks, those tend to be far more appreciative on a car that is driven on a more ritual basis. If your car is something you haul up to the track, all bets are off. You do what you think is necessary. If you use your car far more on the street than you are on the track, think about that for a minute. Do you really need that race-proven, kidney-shattering suspension? In this case, we're not doing that. What we're doing is pay attention to the spring roundings here. We have very little room in these springs, which means they bottom out pretty easy. So we're changing out springs and shocks, as you saw in the earlier video, and we're going to start to take care of a few things, get this thing ready for the road. But for the most part, everything about what we're doing makes a lot of sense. One thing I will certainly agree on, no matter what, moving up to a 29mm front sway bar is somewhat ideal. You have to think about that. There's a very simple application here. The heavier, stronger you make that front sway bar, the less need for a rear sway bar in most applications. You have to trust me on that. We built a mini race car. We're pretty much confident what we're seeing is right. If you do a really strong front sway bar, rear sway bars become far less needed. What happens is when you get this sway bar in place, your rear becomes a little too active. You find yourself correcting a lot more than you need to. Just move the thumb. Opportunity to pretty up everything. Got all the suspension components out. Before I put in the bright new ones, might as well update the undercoating. the other spring, it's probably half the distance of that. Now I've got a little more bottoming out appliance. Much more ideal system. You believe he drove this all the way back up here from California with a blown clutch?
They don't have places in California that will fix that thing?
I would assume based off where he was at in California there wasn't much options. Anyway, so that's what we're going to do to change the clutch out. So anyway, we're going to change the clutch out on this car. Drove all the way back up here from California, about 400 miles I would think. And now it needs to get that clutch changed out. But something I want to talk about. Here's one segment of the drive shaft of any given Alpha. You got the centering bearing, Weebo, mounts the transmission, and you still have the additional other half that goes out to the differential. And because it's on a yoke system, technically 3 yoke system, this is a bit of a horsepower stiller, and these are heavy. So what we are in the final phases of having in our hands is a complete single piece carbon fiber drive shaft with a revolutionary style continuously centering CV joint instead of a Weebo. Now, the reason you don't need a Weebo when you run a carbon fiber drive shaft is because the carbon fiber drive shaft has the ability to deflect about 20 degrees, which would make a Weebo inert. There's no reason to have it. Okay, you're not beating up the differential nor the transmission because the carbon fiber drive shaft is going to give you the necessary torque twist that you have. So stay tuned on that. We should have that, I would think, in the next couple of weeks, and that is going to be quite a special part. We have quite a few people already asking for them, and these things are state-of-the-art. They are extremely well balanced, and it's going to be literally take it out of the box, bolt it in, and go. And you're going to get a lot of horsepower back that you lose from the energy lost from the transmission back to the differential because of the drive shaft. Not to mention, you're going to shave about 20 pounds of rotating weight minimum. Okay, because I'm only going to pull the transmission in one segment of the drive shaft out, I'm not going to take the whole drive shaft out. But with that said, it means I need to separate it right here. If you've never done this before and you need to do it, know this. You need to mark anywhere where the 2 pieces meet right there. You need to make sure you put them back together at the same place, because these are typically balanced as one. So if you were to put this, just to say 45 degrees, out from where it was, you're going to have an imbalanced or an unbalanced drive shaft. You're going to have weak vibration. You might want to make sure you do that. Now the relationship of the 2 pieces via the bolt and nuts right there is a really tight fit. You're going to have to constantly rotate this to make sure the transmission is out of gear when you're doing this. And by the way, drive shaft bolts here and at the differential, those are very specialized nuts and bolts. Don't replace them with something that's inferior. There's nothing wrong with them, repurpose them. They're extremely hardened, they're exact matchings to the bore on the actual hole to the drive shaft. They're very, very special. They're a 9mm bolt with a specific shouldering on them, and they are immensely hard. Very special bolt. So anyway, the exact profile of that nut and bolt is pretty relevant. 9mm, which is probably one of the few places in the entire car has 9mm. The 10.9 hardened bolt with a very specific shoulder on it that is unique specifically to this. Now I promise you, if you go and put some grade 8 or slightly undersized nut and bolt in there, you're going to shear it. And that's going to be a catastrophic failure. throwout bearing isn't really the issue. It's a little bit worn, but it's not in bad shape. We'll take the clutch pack off in a second, see how bad that is. But that's how you take them out. Disconnect the first half of the dry shaft out. You don't have to take out the whole dry shaft. It makes it easier to put it back together this way. And you pull it out. I mean, granted, you gotta get the motor tilted back without crushing the firewall, but other than that, it comes out with a minimum of resistance. Okay, well, if you've never seen a blown out clutch, it's not this part that's usually the problem. It's actually fibrous disc that's in there. Usually, rivets pop loose. Discs are usually fragmented. It's usually not a very pretty sight. One thing you should know is when you go to put all this back in, obviously you need to align it all, but you need to make sure you torque these. Don't take it for granted that you just snuggle up and that's good. It's not. Okay, and that should be it. All right. Okay, well, what we can see right here is already the springs have completely smacked up the flywheel. So that's pretty beat up. Wow. Generally, a complete clutch pack will come with the new throwout bearing, new clutch disc, and pressure plate. Now I'm going to show you how to put that in. But here's the thing, you're going to need some certain tools that if you've never done this before, you don't even want to try doing this without them. One of them being a torque wrench and the other one being an alignment key. And I'll show you what those are all about in a second. So on the onset, I don't need any of those tools just yet. I do need to put this together and snug it up. Now, there are alignment pins all over the flywheel. Make sure you're getting those. At this point, you do not want to snug this up. You just want to get this to hold the clutch disc in place. And again, remember, nothing will be torqued down just yet. I need to align the clutch disc to the flywheel, or we're never going to get the transmission back on. So these are just finger tight. Now this is an alignment tool. The whole point of this is to align the clutch pack, or I should say at least the clutch disc, to the flywheel. Once I have that centered, and you take this out, then I need to lube up the spline in there. If you don't lube it up, you'll find you're fighting to get the transmission into it that much more, so it just makes good sense. So once it's in there, okay, it's bottomed out. Now obviously you don't have to buy one of these really expensive versions of that tool. Alright, you could buy just a simple plastic version of this in just about any parts store. You just need to make sure it matches up to your particular clutch plate, because they're all different. This particular version, what's happening is I'm expanding the flaring on the inside. And once that starts to snug up for me, then I can center up the clutch plate. Okay, so now my clutch pack is actually centered to the dowel on the flywheel. So now, in theory, as long as the splines are offset to the spline on the transmission, it slips in fairly easy. One thing's certain, if the clutch pack isn't perfectly aligned to the actual flywheel, you're never getting your transmission back on. So you need one of these tools. Again, not one of these expensive snap-on ones, but at least get the plastic version of this. So now, switching over to the torque wrench. Our torque wrenches, we have several different sizes. And because I'm going something well under 30 foot-pounds, I only need a 30 foot-pound torque wrench. And we're going to be doing this in 2 stages. I'm going to get everything down to equally at 10 foot-pounds of pressure, and then I'll go back and repeat the process and get everything up to 16 foot-pounds of pressure. The torque specs on these are somewhere in, to believe, like 14.8 or so to about 19. So we're settling in at about 16. That's always been the sweet spot I've stuck with, and I've never had a problem. Okay, that's the first one. That's 10. 10 there. Now, in order for me to get the top one, I need to take the alignment tool out. I'm just taking the alignment tool out now, and I'll double check and put it back in later, make sure nothing moved on me. But I have to take it out in order to get to that top bolt. Being overly cautious with alignment is never a bad thing. Alright, 10. Now I just need to repeat the process and do everything up to 16. There you go, everything's at 16. Double check it one more time with the alignment tool. Yep, everything's fine. Now we'll put a little bit of lube on the splining so the transmission will slip on a little bit better. You don't need a whole lot of this. You're not trying to slick it up. You just want to make sure that the transmission doesn't cut and grind onto the splines. There we go. Now cleaning this up just because I want it clean. Not that it's going to affect the performance any. And then we'll put the transmission back on, and that's it. Okay, so this is a late series spider that we're working on. We're just maintaining it for this customer. It's a daily driver. The customer's complaint was that when he hits an impact somewhere, it gets a little bit of a rattle and he doesn't like it. It creates vague steering, and that's okay. What we found out was that the ball joints and everything on this car are just fine. If you ever have that rattling or vague steering experience in your car, you need to find out what it is. It could be potentially dangerous. And I realize you can't really see what I'm doing, but I'm moving that back and forth, and I can feel a little bit of bumping around in there. When we inspected the ball joints, none of the ball joints are in fault. In fact, all the ball joints are in really good shape. But what we did find was that the idle arm is moving quite a bit within its actual shaft. So we ordered up some parts and we have them on the way. They'll be here in a couple hours. So we're going to change the idler arm itself and the bushings inside of it. This is somewhat of a common problem. Now, this being a fairly late series Spider, you would think that wouldn't be much of an issue because it doesn't have a whole lot of miles on it, but here's the hook. When you upgrade to larger size tires on your car, regardless of what year it is, or you put in bigger wheels and you add that additional weight or sizing or gripping to the road, you're putting a lot more load onto the components than what the car is actually designed for. That's not so much the case in this, but for those of you out there who have the nice wide tires and wheels on your GTs and Spiders, you are putting additional stress on the car. Granted, you're creating a lot of grip, and that's a good thing, but the car was never designed to have that much lateral grip. Alright, here's the idle arm. A little loose. You prefer to see it a little stiffer than that. When you go this way and that way, you can feel it shifting around there. It just means bushings aside, and possibly the arm, completely worn. I'm going to take this over to the parts washer, clean it up before I crack it open, because I don't want to contaminate the bearings and things that are in there. The point is this is something you can do at home. Good inspection of the steering links and everything will indicate where your actual problems are at. I know what mine are. Okay, so we've got everything cleaned up on this, and basically what we have found is that the bushings in there still have their coating on them. There's very few scars in there from witness markings. However, the arm itself is completely corroded and eroded away right where it comes in contact with the brass bushings. So when the parts get here, we'll see if we just need to change out this. We're going to change out this and the actual bushings itself. But right now, I'm hedging my bets that only this needs to be dealt with, because in there it's brand new almost still. Alright, so we're lucky enough to get a factory original rebuild kit. And that's rare. The downside of that though, however, is this, the pin, is welded on to these, so you have to remove that. And secondly, the replacement one, you got to weld it back on perfectly squared, or this thing have nothing but problems later. If you're wondering what I'm doing, I'm cutting the weld the pin is attached to on the arm. It's kind of a tricky job because you don't want to cut the actual arm itself with big borders. Now that I've done that, I need to remove some of the loose debris so I have more of an access to it. Okay, so the old pin's out. Even though you have to press it out, because it takes about 6,000 pounds of pressure to get this thing out, you still need to clean up before you cut the weld. Because if I try to weld over that, I'm not going to get a good quality penetrating weld onto the new rod and to the arm. And you're most likely going to have to heat this up with a torch to get it to let go of this. Because I use a plasma cutter, this already got superheated to where it gave me enough room for this to free up. Okay, there. I got all the burnt carbon out from cutting out the plasma cutter. Now I'm ready to put the new one in.
Munoz at Vintage Customs. So what I've done already at this point is I've mocked up the headliner, and with that headliner being micro suede, when I mocked it up, it read everything. And what I mean by read everything is it read this metal piece here, it read this metal centerpiece between the A and B pillar, and once it read all that through that suede, there was no way that we were going to get away with just having the sound deadener and the silverback juke. So what I've done at this point, and I've taken 1/4" scrim foam, and we have lined the entire lid of this car with it. So now what I'm going to do at this point is I'm going to take that suede headliner and free float everything. And what's going to happen is this 1/4" foam is going to give it just enough cush that you don't read all this metal through that suede. I still got to cut out the ring for the halo, but at this point, baby steps and we're moving on. Munoz again, back on the GTA project. You can see that I had to add some scrim to the A pillars. I've got my bow for the headliner in place, and it's kind of hanging here. So what I'm going to do is temporary glue these sides. Then I'm going to temporarily glue my front. I'm going to pull this back, cut out my halo, and then we're going to start stretching it from there and working myself from the back to the front. And that's where we sit at this point.
Munoz here again. I think the last time we saw this, it was mocked up inside the vehicle itself. And what I've done is I mocked it up for the halo ring. Once I made my marks, pulled it back out, cut out the hole, glued it to this ring. And now what we're gonna do is we're gonna put it back in, install the ring, install the bow, and then start stretching it from there. So little by little, baby steps. As you can see, I've got the headliner in, got the halo insert in, and I've got my bow in. So now what I want to do is I'm going to stretch this front out, but I have to pay attention to this stitch on this bow. This is what's got to be important. That thing's got to be as straight across as possible. So if I start stretching in the center, and that thing all of a sudden starts getting a wave in it, then I'm just going to be chasing a wave. So I've got to do as much as I can to get this seam line straight. From there, all that I'm doing from that point is spraying this edge with glue, spraying the body edge with glue, heating it up so it kicks off, stretching the crap out of it, and wrapping that thing around. So it's just baby steps, little by little, working my way to the back.
So as you can see, I started at my center, and now what I've got to do is I'm working this way and then working this way. So once I get it straight across from front, then I can start working on my side to make sure that I pull all this taut and make sure that this thing is kind of straight. You can see that I've got a little bit of a wave that I have to adjust. So what I'm going to do is literally pull this off now, re-stretch that, and get that thing straight.